Hello everyone. In this video I'm going to talk about integration of large language model with network topology. So the user is interacting with large language model, and if a query of a user triggers a tool call, it gets served by MCP server. MCP server has access to various data sources, and in this case it's just SR Linux based switches using GNMI, JSON RPC, and SSH protocol. Now the question is, what type of query can trigger a tool call? For example, if a user says he needs to know all the interfaces available in Leaf 1. Now there is no way for large language to know how many interfaces there are in Leaf 1, and therefore it has to ask the switch itself to determine how many ports are there, and it will do it through MCP server because MCP is acting as a bridge between large language and various data sources. Now let's have a look at the topology. It looks like, so we have 3 leaves and 2 spines. eBGP is running between them for advertising system IPs, and eVPN based overlay is running for services. And that's what the control plane looks like, and for the forwarding plane we'll be using VXLAN. Furthermore, we have 4 different clients: client 1, client 2, client 1, client 2, client 3, and client 3 by 3. 1 and 2 are in the same subnet, whereas client 3 and client 3 by 3 are in different subnets. Now let me show you what is configured on the devices at the moment. So if I run network summary, I can see that there is on the default and management network instances. So there's no instance available for services. Same in Leaf 2 and Leaf 3. But we are running BGP pairings for underlay and overlay. Let me show that. Call BGP neighbor. So the first 2 pairings are using IPv4 address families for underlay, and the second 2 are for using eVPN address families for the overlay services. And yeah, so let's have a look at the clients. Yeah, on the client side we just have an IP address configured on the interface on VLAN 100 on client 1, same in client 2 but with a different IP. This client is behind Leaf 2 and this client is behind Leaf 3, and it is in a different subnet, and there is also a route configured, so I can show you that. So the route says that the gateway is 254, and here the gateway is also 254 of its subnet. Now this large language model is integrated with the network I was showing you earlier. So let's run basic show commands to see whether it is able to fetch information from devices or not. So for example, can you fetch the MAC VRF and IP VRF configured on Leaf 1? Okay, let's see. Seems like it's trying to fetch the information. So yeah, so there's a default and management network instances, just like we saw earlier. So let me ask another question. Can you show me all the interfaces available in Leaf 1? So all the interfaces available in Leaf 1 are shown over here, and in fact, you can get a nice looking table. So let's say if you want to show it in a presentation or keep it as an inventory, you could even ask the LLM to give a nice looking table. Can you create a table in HTML showing all the available interfaces in leaf 1. Okay, seems like it's trying to do something. Let's see, let's wait for a while. Bear with me. Okay, now you can see that this is a very good looking table over here, which you can use for later references. Okay, now let's try to do something interesting. Can you create a Mac VRF with ID 100 on leaf 1 and leaf 2? If you remember, client 1 was connected to leaf 1 and client 2 with leaf 2, and both with VLAN 100. So they were in the same layer 2 domain. So let's try to configure that. Okay. Okay, so it's saying that the interface, the Mac VRF is created successfully, but there is no interface associated yet. So can you associate interface Ethernet 1/10.100 on both leaves? Okay, so seems like it has successfully configured it, and let's see if it really is the case. So the ping between the leaf 1 and client 1 and client 2 should now work. Let's see if it works. Yeah, it is working. So let's see what happened behind the scenes. So let's go here and check the network instance. Yes, so we can see that Mac VRF 100 was created. So let's see if there's any interface associated with it. Yes, there is an interface associated with it. Okay, and now you can even ask some weird questions like, are you learning any Mac from interface Ethernet 1/10 on leaf 1 and leaf 2, and let's see if it can find it. So it's trying to look for the MAC addresses. It again triggered a tool call, and you can see that there is a MAC. So it has learned this MAC. So let's see if it really is true. So according to the LLM, this MAC should be available on the leaf bridge table. Let's see. Table, and sorry, all. So I can see, let me paste the MAC, and yes, it found the MAC which is installed in the table. All right, now let's move on to the next section. Notice that I did not configure anything on leaf 3, and I did not enable inter-subnet communication. So therefore, if I try to ping from client 1 to client 3, it will not work. And if I try to see what is happening, what is configured on leaf 3 so far, and there is nothing, no network instance, no interface associations, etc. So let's not do that. Next, create MAC VRF with ID 200 on leaf 3 and associate Ethernet 1/10.200 with it. Okay, let's see. So the tool calls are triggered, and let's see. Okay, so according to LLM, it's already configured. So let's verify it here. You can even ask LLM directly. So it seems like there is a MAC VRF with the name of 200 and interface associated with it. Okay, the ping should still not work, right? So we need to now create IP VRFs. Can you create IP VRF with ID 1000 on leaf 1, leaf 2, and leaf 3? All right, let's see. Okay, so apparently the IP VRF has already been created. Okay, so next I can say that I want to associate. So let's see. So it says currently network instances leaf 1, leaf 2 with and leaf 3. This is configured in IP VRF. You can now associate them. Okay, so now let me associate the MAC VRF with IP VRF. Okay, can you associate MAC VRF with IP VRF, MAC VRF 100 with IP VRF 1000 on in leaf 1 and leaf 2. Okay, so notice that I missed one thing. I did not tell what Anycast IP should be. And let's see, will it ask me to provide the Anycast IP or not? Okay, it didn't ask me, it just simply configured it. So now what I'm going to do is I will tell it to replace the Anycast IP. Can you use Anycast IP 192.168.100.254 instead of 192.168.100.1/24. Okay, so it says it's trying to update. Okay, let's see. So notice that it's deleting the association first, just to make sure everything is clean before making the changes. Now it's reassociating MAC VRF and IP VRFs, and yeah, so now the Anycast is configured already. So let's see. So now the gateway IP should be pinged up. So the gateway should be 254 if you remember. So now, yeah, so the gateway IP is pingable, and it should be pingable for the client 2 as well, because it's configured on leaf 2 as well. Okay, so gateway is configured. Now let me do the same thing on leaf 3. Associate C8 MacBRF 200 with IPVRF 1000 on leaf 3. Use Anycast IP 192.168.200.254/24. Okay, so apparently it is now configured on leaf 3 as well. So we should be able to ping, if everything goes well, the other subnet. And guess what? It's working. So basically what has happened so far, so let me go back to the topology. So there is a client 1 connected to leaf 1, client 2 connected to leaf 2 in the same subnet, and client 3 connected to leaf 3. And layer 2 extension between leaf 1 and leaf 2, and layer 3 extension between leaf 3 and leaf 1 and 2 has been established. Very good feature in cloud, where you can simply store your template that works. So you don't need to think about what questions to ask for your network to your configurations to work. So simply I can go here and say I want generate a prompt for me. So I just need to fill the placeholders. So zone 1, so we have 2 zones in the topology, zone 2, and then I can say the ID here is 100 for zone 2. So client 1 and client 2 both are in zone 1 and both are sharing the same ID, and client zone 2 client 2 is in client 3 sorry is in zone 2 and is sharing MacBRF 200. So 1000 should be configured in both zone 1 and zone 2. And finally, the Anycast gateway here should be 192.168.102.54.24, and similarly it should be 224 here. So we do that. And, okay, so let me tick and see what happened. So a prompt is created over here, and it says that on availability zone 1 configure below, create MacBRF 100 using MacBRF tool, and then create blah blah blah. So everything that we did earlier. Okay, so let me copy it. So if you remember, there was nothing configured, everything was reverted back. Let me reconfigure it by pasting this prompt. In the meanwhile, let me show you what this service mapping file is. Okay, let me go here. Service mapping file. So it's just a simple service configuration, how your network is actually configured, what interfaces are attached to leaf 1, what zone is it associated with, etc. Okay, let's see. It's associating the MAC and IP. Now configuring the zone and services. Okay, so the configuration is complete. So let's see. Let's go back to the devices and see what's happening. Show network summary. Yep. What about here? Show network summary. We have IPVRF, show network summary. And then let's try to ping again. Let's ping 100.2 100.200.3. Oh, 200.3 is not working. Oh, it's working. Great. Let me revert back again and show you another prompt. So in the real world, you'll still not be writing a prompt if you have thousands of services running. So it's more convenient to create a file and then simply define what services you want to be pushed on the devices. So that's what I'm going to do. So let me open the services files one more time and see what it looks like. So if you see the service file, you can see that there are two zones, and in the first zone we have these interfaces, and the MAC VRFs here in this example are 400, 300, 500 and 700 in zone 1, and there are 200, 400, 600, 800 in zone 2. So what I really want to do is simply tell the LLM to use this file to configure the network devices. So first step is we need to revert back. So can you revert back all the leaves to starting point? Checkpoint. Okay, so this was the very first state of the network. Okay, it's reverting back. Okay, so revert back is successful. Let me quickly ask, what MAC VRF and IP VRF are configured on leaves now? Okay. And following is configured. None configured. There is no MAC VRF. It's just the management and default. Okay, so it has successfully reverted back. Everything has been removed. Okay, now let's try the second template. So the second template is the file template. So let me click. So it says that simply configure below devices using the service mapping file, create a rollback, a checkpoint before making any changes. So it's simply calling the file and configuring the services mentioned over there. Okay, so okay, let me let's see. So now we should have these services configured, not just 100 and 200, but the whole list that is mentioned in this file. Okay, it will take a while. So in the step 1, rollbacks were created. Step 2, Mac VRFs were created, and in leaf 1, leaf 2. So notice that the tools were called 4 times because there were 4 entries in the list for zone 1. So 100, 300, 500, and same for leaf 2. And now the interfaces have been associated. Mac VRFs have been created. Okay, what's next? So 200, 400, 600, right? 200, 400, 600. Yeah, exactly. And creating interface and associating with Mac VRF. Okay. So the complete configuration is now complete. So what are we expecting now? There should be like some Mac VRFs here. So network instance, Mac VRF, and you can see that there are many Mac VRFs configured now, right? And let's do the same here, and let's do the same here. Okay, and finally this ping should still be working. Okay, once you have configured everything, maybe you want some sort of verification to be done, right? So there are 4 verification points that I have mentioned in this prompt, which is get the Mac VRF details, what Mac VRFs are available, what interfaces are available, what Mac addresses are being learned, and what are the associations of Mac VRF to IP VRFs. The association. Okay, so let me do that. It's verifying it. Okay, perfect. I can see Mac address is active. Mac, okay. IPVRF associations. Let me check the IRB interfaces and associations. Okay. So the verification summary is now ready. Okay, now let me request LLM to store this in a file. Can you store above results in a file with timestamps? Okay, let's see. So the LLM also has access to one of my network directories. It will simply store the logs over there. Let's see. Okay, so apparently it has stored the data here. So let's see if we have the file now. Let me cat here, and yeah, so the whole report of what was done during the configuration process is available over here. So far we configured everything using large language model and everything was working fine, but what if I missed something? What if I forgot to tell large language model what interfaces should be associated with the bridge, and what if the client, there is a problem on the client side? Will large language model be able to figure it out? Let's find out. Okay, so let's see what I did first. So there was an interface called 1/100 which is connected to the leaf. I intentionally brought it down, and on the leaf side, the interface that was connected to the client tool has been removed. So if I do this, show network summary network Mac interface, there is no interface. Okay, this has been removed. So let's ask large language model. Okay, so let's start a new chat. I am trying to ping client 2 from client 1 and it is not working. Client 1 is connected to Ethernet 1/10.100 and client 2 is connected to Ethernet 1/10.200. Okay, sorry, not 200.100 of leaf 2 and of leaf 1. Okay, let's see. It's trying to figure out the issue. Let me check the VRFs. Okay. Okay, so he's saying here that let me add the interface 1/100 over here, and it found out that this was the issue. And obviously, even after configuring this interface, the ping will not work because there's a problem on the client side. But let the LLM finish first. Okay. Okay, now obviously if I ping right now, it should still not work because there's a problem in client 2, but I think that LLM has added the graph here. Yes, sure enough, it's been added. Now let me tell large language that it's still not working. It is still not working. Okay. So just so that LLM can get some statistics or MAC entries. Okay, so he's saying that found a critical issue. Looking at leaf 2, I can see key findings. Ethernet is up, no MAC addresses learned, statistics shows 0 inputs, no ARP entries, etc. So therefore there's a problem that indicates that there is client 2 is likely not connected or not transmitting any traffic. So yeah, and we know that that's what the problem is. Okay, so let me configure it. In fact, it has even given the configuration. So okay, anyway, let me go here and bring it up. And if you notice that exact command is shared over here, only the interface is different. Anyway, so let's see. Yeah, so the ping is now working. Thank you.